Hello everyone, my name is Franco Dubois and I'm a PhD student of the University of La Plata and working for the Sindeca CONICET Institute. Our work is titled Recycling of Spent Lithium-Ion Batteries, Low Temperature Dry Reforming of Methane Application. The dry reforming of methane is an important reaction of interest for the treatment of biogas and for the production of hydrogen. In this reaction, CO2 and methane combine to obtain the mixture of hydrogen and carbon monoxide called syngas, which is a valuable feedstock for the production of chemicals and fuels. This reaction bears problems due to the deactivation of the catalyst by secondary reaction and the requirement of high temperatures. For the catalyst, it's preferred the use of transition metals like nickel and cobalt. Today, a big problematic is the disposal of spent lithium-ion batteries. In the study of recycle and reuse of its components, the cathode material is of interest because it usually contains metals like nickel, cobalt and manganese. In our work, our research group focused on the recycle of lithium-ion batteries through an hydrometallurgical method to obtain a leach of the metal present in a cathode material of a spent battery and incorporate these metals in a support to obtain catalyst for the dry reform of methane at low temperatures. This table shows some results of the characterization of the prepared solids by wetness impregnation over gamma alumina support and calcine at 600 degrees. The solid named LX1 and LX2 were impregnated with the leached solution with rising concentration. For comparisons, two more catalysts with the same metals were prepared with commercial salts. The X-ray diffraction pattern detected similar phases of manganese and cobalt oxides and didn't detect the phase nickel oxide phase, which is believed to be well dispersed over the surface due to interactions with other metals present. The scanning electron microscopy showed significant difference in morphology, where the catalyst prepared with leached solutions presented peculiar filament structures over its surface. TPR studies were conducted and showed that at 600 degrees a good proportion of nickel were reduced. The dry reforming test conducted at 600 degrees showed comparable levels of conversion between the leach and the commercial salt catalyst. The hydrogen monoxide relation obtained was about 0.9 at 3 hours test. For conclusion, it's possible to use a chemical recycling for the recovery of important and high-cost metals such as nickel and cobalt for spent lithium-ion batteries, and use these metals in the synthesis of solid catalysts that have a potential application in industrial reactions, such as the dry reforming of methane. The performance and conversions of the catalysts were comparable to the commercial ones and give an hydrogen-carbon monoxide relation near unity. Thank you very much for your attention.